This is a recast of the 7,800-word piece. Frank Rosenblatt, creator of the Perceptron and AI pioneer, from AI VIPs. Let's listen in.
Starting in the mid-20th century, a rising interest in artificial intelligence, AI, and cognitive science led to the development of models attempting to replicate human intelligence. Among the pioneers was Frank Rosenblatt, an American psychologist and computer scientist. His invention, the Perceptron, is seen as one of the foundational contributions to the development of artificial neural networks and modern AI.
The Perceptron was a significant departure from traditional rule-based AI systems. It introduced a model of how neurons in the brain might function to process information, which provided the framework for machines to emulate learning processes. Rosenblatt's Perceptron became a bridge between cognitive psychology and artificial intelligence.
Not just that, Rosenblatt envisioned a future where machines could simulate human cognition, learning, and reasoning, ambitions that continue to shape the core of AI development today. His Perceptron was capable of learning from its environment. It was the first step toward teaching machines to recognize patterns, a concept that dominates AI research today.
While there was criticism and the Perceptron was overshadowed by other AI methodologies in the 1970s, it experienced a resurgence decades later when more advanced neural network models proved that his early ideas could be built upon to solve complex problems.
Now, let's delve into what exactly is a perceptron. The perceptron operates by summing the weighted inputs and then passing the sum through an activation function, which determines whether the output should be activated or not. It begins with an input layer, which receives raw data. Each input node corresponds to a feature or a piece of information that the machine needs to process.
Between the input and output layers are weights. These play a crucial role in determining the importance of each input. The weight of each connection is adjustable, and through training, the perceptron learns to assign appropriate values to these weights.
After the input data is processed through the weights, it is passed to the output node. The output is typically a binary classification, where the perceptron decides whether the input belongs to a certain category or not.
One important aspect was its ability to learn from experience. Unlike traditional rule-based AI systems, Rosenblatt introduced a supervised learning algorithm that allowed Perceptron to adjust its weights based on feedback from its environment. This form of learning foreshadowed much of what deep learning and neural networks aim to achieve today.
Rosenblatt's Perceptron received some serious criticism from Marvin Minsky and Seymour Papert, who highlighted its limitations like its inability to handle complex problems. This critique played a role in temporarily stalling perceptron research.
However, Frank Rosenblatt's contributions were far from being forgotten. They paved the way for modern AI and continue to influence it today, especially in today's era of intelligent machines like deep learning and neural network architectures used in fields such as computer vision, natural language processing, and autonomous systems.
Today's neural networks with many hidden layers, powered by sophisticated algorithms like backpropagation and reinforcement learning, are now capable of tasks that once seemed like science fiction. Rosenblatt's perception, though flawed, remains a crucial stepping stone in the journey toward creating intelligent machines.
That's it for today.